Good evening, class, and welcome to another day with me on performance management. My name is Chima, and I'm your teacher for tonight. So, the topic we are going to be discussing tonight is called Learning and Experience Curve Theory. Now, learning and experience curve theory is a topic that is now frequently featuring in your examinations. And that means that you have to take this topic seriously because many students are known to be failing a question from this topic. Many times, people who pass this question from this topic are not much. Now, I'm going to be sharing with you some secrets on how to pass learning curve. And so, pay attention for the rest of the class. All right, so what is learning and experience curve? Okay, so when you start a job that you are not so familiar with, everything seems to be double. Everything seems to be Greek to you. Okay. You know, these days, sometimes people apply for a job that they are not really suited. And even if they are suited, so to speak, they don't have experience. So you see that word experience. What is experience? You have done something over time. Now, imagine someone making bread for the first time. You just want to start baking bread or just want to start baking cake for the first time. Okay, that is even too far. Imagine somebody just fresh out of school or fresh out of ICANN or any professional course, and you want to start teaching performance management. You have never taught before. How do you think that will be? That will be quite an experience because you'll be making lots of mistakes. Okay, let's go now to bread. You are making bread for the first time. You might be wasting a lot of materials because of inexperience. You might also be wasting a lot of time making your first bread. And so by the time you do your first bread, do the second, do a full bag, you not start making several loaves of bread, you are learning on the job. So you see that word learning is affecting the whole process. You are learning on the job. Okay, so let me use myself an example. When I started teaching performance management, and now as I'm teaching performance management, you'll see that a lot of experience has gone down the path, my pathway to teaching performance management. When I first started teaching, you know, students will ask some questions that will throw you off balance. Sometimes you may need to study a particular topic severally so that when you come to class, you do not mess up. That's what learning and experience does to you. So sometimes you make mistakes, you are being forgiven because they will excuse it and say you are learning on the job. Now, it is good to know that you are going to be learning on the job, but there comes a time when you will have finished your training, you would have finished learning. And how will we know that you have finished learning? It means that your efficiency will not improve more than you have achieved so far. Okay, let's say, for example, you are baking bread and one loaf of bread takes you, okay, let's say one batch you put in the oven takes you 3 hours. Everything, 3 hours. Okay, no, 3 hours is too close. Let's say it takes you 7 hours to make one batch of bread. That's too much time. Okay, then due to some experience your part, when you start doing it second time, the third time, you now start going down from 7 hours to 6 hours, 30 minutes, 6 hours, 5 hours, and perhaps when you now go to 4 hours and you don't go below 4 hours. Now, that is your highest efficiency. You have finished learning. And so that is what is called the steady state. So you are now going steady. Now, what is the advantage of knowing this steady state? Now you can use it as a planning tool. So you will just wake up one day and say, okay, I want to make 3,000 loaves of bread. How many hours is it going to take me? How many batches am I going to make them? So you can plan with it because you know your steady state. But when you are still learning, it might be difficult for you to plan. So you see, now, when you go about and see people telling you, look, you can't teach me my job. Are you going to teach me my job? Just know that these are experienced people. Learning curve has taken place and they are now in their steady state. So you see sometimes people in the job market, they want to get people who have experience, who have gone through the ropes of learning experience curve, and they don't want to make mistakes. Also, people who have written performance management more than once and you are learning, it means that you're obeying the learning and experience curve. You'll be far better to handle performance management than someone who is writing it for the first time, because you are familiar with the questions, you are familiar with how PM can destabilize you, and you are ready for it. Now, there are two ways in which we can solve learning and experience curve. The first one is using the tabular approach. Now, the tabular approach has its advantages, but it has its own drawbacks. Now, the formula approach, the tabular approach is so simple. You just have to put a tabular and you put the figures. But what is the drawback? The drawback here is because of how learning curve is being looked at. Now, this curve, learning curve, when drawn on a graph, it has a steep at the beginning. You see the graph coming from up, down, and it is going on the curve. So at the beginning of your learning, you have a steep curve. Then when you get towards the steady state area, after some period of passage of time, the curve becomes less steep until it becomes a straight line moving in the x-axis or parallel to the x-axis. Now, what is all of this about? Learning curve simply says that as production increases by 2, or let's say as production doubles, the rate of learning falls by a constant percentage. For emphasis, let me take that again. As production doubles, cumulatively. As production doubles cumulatively, the rate of learning falls by a constant percentage. What do we mean by that? It means that if you start making bread, as production doubles cumulatively, that means from the first loaf of bread to the second loaf of bread, production has doubled. The rate of learning falls by that constant rate, which is called the learning rate. So if your learning rate is 70%, or let's say 80%, it means that from the first bread you are making to the second loaf of bread, your learning rate is going to fall by 80%. It means you're going to make like a kind of 80% improvement from the first to the second. Now, when you move from the second to the fourth, so we're looking at cumulative movement. So from the first two loaf or first two batches to the next two batches, which is the first four batches, the learning curve will also be noticeable, falling by that same constant percent. And so that is how the tabular method is being observed. Now, the problem with the tabular method is this, okay? You move from one batch to two batch, from two batch to four batch, from four batches to eight batches to 16 batches. Now, how would you observe the movement from batch 2 to batch 3? Or how would you observe the movement from batch 8 to batch 9 or to batch 10? So you can see that that is not being handled by the tabular form. And so we need to get a formula that will help us to handle any volume that we consider. And so that's why we come to use the formula or mathematical approach. Now, the formula for learning curve is this: y, which is the dependent variable. So y equal to, meaning that y is dependent on a, x, and b. A, x, and b. Now, in this equation, y equals to a, x raised to power b. In all of these, x is the independent variable. X does not depend on any of these variables. But you can see that y depends on a, y depends on b, depend on x. Can you see that a is a constant? A is a constant. What is a constant? A constant is a number that is written in front of a variable. For example, we have 2x, 3x, 5x. The 5 in 5x is a constant. X is the variable. So 5 is written before x. So 5 is a constant. It means that a is the constant. A is constant and does not change. So you see, that is why it is constant. B is another constant. B is another constant. So sorry, A being at the back, being at the front of x is called the coefficient of x. It's a constant, yes, it's a constant figure, but it's the coefficient of x. So when you see 5x, 5 is the coefficient of x. When you see 2x, 2 is the coefficient of x. When you see x standing alone, there is an invisible one by the side. It means that is 1x. 1 is the coefficient of x. Now, B is called the exponential or the exponent or the power of X. It's another constant. B is the power. That means X has been raised to the power of B. So it means that if B is 2, it means you are making X to appear 2 times. If B is 5, it means X is appearing 5 times. So X is being raised to the power of B. So it means that B is affecting X alone. And now B is also an independent variable. Though it's a constant here because B will never change. It's also a dependent variable. Depending on what? Depending on log R all over log 2. Here, in this second equation where we have B equals to log R all over log 2, log R is the independent variable. R, I mean, is independent variable. R could be anything, and R could be your learning rate. So your learning rate could be anything. But once R has been used to form B, B is now a constant which Y depends on. So what are the real parameters that we are using here? Y is the cumulative average time per unit for all the units made. Let me explain. In learning curve, we are going to be doing something called cumulative. What is cumulative? When you were in university, you have something called cumulative grade point average. What does that mean? It means you wrote an exam in year 100 level year 1, and you passed, and you have a GPA, grade point average. The GPA for that exam becomes your cumulative for that period because you are just starting. You go to first year, second semester, and you wrote an exam, you got a GPA for second semester. But now you need to get what they call CGPA. What is CGPA? Cumulative grade point average. And now that's cumulative grade point average will be taking your grade point from 100 level first semester, 100 level second semester. Now you went to year 5 or year 4, so to speak, whichever number of years you finished your school. Let's say year 4, second semester, and you wrote the exam, and you have, say, 4.5 or 4.8 in that exam. But when you now calculate your cumulative grade point from 100 level first semester to 400 level second semester, it brings you to 2.5. So you see how the cumulative has made everything average. And so you see, cumulative will start from the origin to the present, from the very beginning to the present. So you see now why is the cumulative average time per unit for all the units made. It means that by the time you start making that bread, when you start making your first bread, you start making your mistakes, even that 7 hours, it's going to pick it. Now, when you are making your 50th bread, the time it takes to make your first bread, your second bread, up to your 50th bread is going to add everything and divide by 50 to get an average cumulative. So you are starting from the very first time you started your baking to the present, cumulative. So let's get that point clear. Now, what is X? X is the number of units made so far. Now, it will interest you to know that it's also cumulative. So it means that if you are making your 50th bread, X is 50. It means you are making, X is now from the first bread you've made Add everything to what you are doing now. You've made 50 loaves of bread. Cumulative. Now, A is the time for the first unit. It's either the first unit or the first batch. And I told you A does not change. So the first time you spent making your first bread, let's say it is 7 hours, it will remain so. First impression, lasting impression. So the first time you made the bread, the time you take to make the bread is being captured. So you can imagine, okay, let's say some people are capturing their progress, maybe when they first came to an environment or they first start working somewhere, they capture the moment. Or maybe some people, when they are taking a public speaking course, the way they sounded when they first started, they capture it. And now they sound polished, they capture the moment and they say, okay, this is how I have progressed so far. Now, A, in this sense, is the first time, the time taken for the first unit. It doesn't change. It's a constant. What is B? Your B is the learning factor. The learning factor. It also does not change. And what is R? Your R is the learning rate, which must be expressed as a decimal. It means that if your learning rate is 80%, you have to express 80% as 0.8. So your R should be 0.8. Now, putting all of these together, we will have created the formula that we'll use for our learning curve. Now that we know how to write the formula, please remember this formula, although it will be given to you in the examination, but the important thing is to know how to use the formula. Before we use this formula, let us get some general steps for solving learning curve problems. I want you to take note of these steps that I develop here. It will help you in solving learning curve problems. Step number 1, observe if the unit of measure of A is stated in units or batch. Now, there is a difference between what we call unit of measure and value of measure. Let me explain. Unit of measure. If you want to measure flour, what is the unit of measure for flour? Is kilogram. So check if A is measured in maybe units, either 10 units or 5 units, or is in batches. You know, a batch is a combination of several units. So if it is in units, take note of it. If it is in batches, also take note of it. Okay? So there is a reason why you are taking note of it if it is units or in batches, because what is given to you as A will always remain so as you solve. Now, these should be consistently used. Now, see something. If A is stated in batch, then if subsequently they give you units, you need to convert those units to batch. If A is given to you in units, then subsequently they start telling you about batches, you need to convert those batches to units. So if they are telling you units and you say batches, they will always tell you the batch size. When we say batch size, it means how many units make up a batch. That's the batch size. So how will you know if the unit of measure is in batch or in units? Watch out for when they are telling you the first the first observation. So watch out. Is it given to you in units? Be very careful, be very observant, or batch. Second step, check if the value of measure of A is stated in hours or in naira. Now I said there is a difference between units of measure and value of measure. Let's go back to bread or the flour. How do you measure a flour? What is the unit of measure of flour? Is in kilogram. What is the value of a bag of flour? It will be stated in naira. So when they say what is the unit, it's in kilogram. What is the value? It's in naira. So check the value of measure. If they state it in hours, then that's fine. Always that you now know that all your answers will be in naira. So the value of A dictates how your answer will be. If your A is in naira, so everything will be in naira. If your A is in hours, everything will be in hours. So take note, if you are given that the first batch of bread took 7 hours, two things have been said here. Unit of measure has been told you as batch. Value of measure is in naira. These are the things you should observe. Go to step 3. You are done with A, you are now with B. Check if the value of B is given. Many times, the value for B will be given. If they are giving you, then no problem. Then you skip step 3 because it has been given. But if it is not given, you must work out your value for B. Now that is where you now use that second equation, B equals to log R all over log 2. So that's when you will now look for that and write your value of B. Now, even if you are given B, sometimes it is good for you to work it out to see if the value for B is correct, whether they must have done some transposition error. Sometimes you may want to they want to write 0.12345. You may end up writing 0.12455. And so you don't want to be using a Reynolds figure. So you have to check if really your answer when you do your B equal to LR all over log 2, log R over all over log 2 is the same as what the examiner is giving you. When if it is the same, fine. If it is not given to you, then you work it out. If it is not the same, use the one you've worked out. So it means that you have to work it then in your answer sheet so that the examiner knows what you're doing. Step number 4, you are now looking for the value of Y. I said it before, X is independent, meaning that X must be given to you. So you don't need to bother about X. So you are looking for A, you're looking for B, you're looking for Y. You have to find Y using the learning curve formula. I said before, Y is the dependent variable, X is independent, X is always given. The next thing to do after Y is to find the value of T. What is T? Now, T is an introduction to what the formula is saying. T is the total value, while Y is the average value. All right, let's look at it this way. If I ask you to find the total age, what is the total age of the students in PM class? You will add student A's age to student B age to student C age, right? Fine. When you add them together, you have gotten the total age for the class. Okay? Now, when you want to, if I ask you to look for the average age of these students, what do? You find the total age and divide it by the number of observations. You find the total age and divide it by the number of observations. All right. Now, normally, we usually look for total first before you get an average. So because normally you want to say average equals to total divided by the number of observations. But looking at your learning curve formula, y is equal to ax raised to power b. Y is average cumulative time or average cumulative cost. Y is average. So you see, in this situation, you are looking for average first. In the normal situation, you are supposed to look for total first, then you get your average. But now our formula says, look for average first. And you need your total. So you have to make your total, your T, the subject of formula. So when you do that, you are getting your X multiplied by the average value will give you your total value. I believe that was clear. We go to step 6. In step 6, we are going to repeat step 4 and step 5. In step 4, you are looking for the value of Y. In step 5, you are looking for the value of T. Why are you repeating step 4 and step 5? Because you want to look for something called incremental value or your steady state value. Don't worry if you don't understand these steps at this time. When we are solving questions, you will see how we will apply these steps. Then look at step number 7. Find the incremental value, which is denoted as small t. So can you see there is a big T, which is the total value, and the incremental value, I call it marginal value, which is like the small t. Using the formula, small t is equal to the big T sub n, we can of course put x there, minus t, big T sub x minus 1. What does that mean? It means if your x happens to be 5, your x minus 1 will be 4. It means that you are looking for the incremental value moving from batch 4 to batch 5. That is what that T means. The time it takes you to move from batch 4 to batch 5, it means you now have the total value of 5 batches minus the total value of batches, which will give you the time taken to move from batch 4 to batch 5. Now that's step 7. In step 8, you have to use the value of T you've calculated in step 7 to multiply the remaining number of units or batches. Immediately you have gotten your steady state. Now, you are doing that because you want to get the remaining number. So you see, this incremental value you just got in step 7 is going to help you for your planning, because at that point, learning has stopped. And so you want to use that incremental value to plan how many hours is it going to take you to do the remaining batches after the learning stage. In step 9, you are now looking at your total labor hours or labor cost, depending on the value given in step 2, by adding the value of T before the steady state to the value of T after the steady state. Okay, so Mind you, the learning curve is used to look for labor hours or labor costs. Labor hours or labor costs. Okay, so that is what we are using it for. It means that learning curve is something that helps us to understand how our labor works. It is labor intensive. Now, what are some of the characteristics of learning curve? One, it must be labor oriented. Manual labor is involved here. Now, if you are to use machines and machine is just doing the job, machine cannot learn. Machine has a certain level of efficiency, and so you cannot be learning on the machine. So machine cannot be learning, it's humans that learn. So there must be manual labor involved. Secondly, the kind of labor is not something that is easy, very easy. So that means it's something that's sufficiently difficult, but not too difficult. So you have to learn and learn until you get to a steady state. Then thirdly, you must have your labor turnover rate should not be changing. Your labor should be fairly constant. It means that the people you had at the beginning of the year will still be the same number of people you are having at the end of the year, the next year, because they are having experience. If all these experienced people now leave your company, you find out that you cannot plan anymore. You are bringing more people, you are going to teach them, they are going to go through the learning stage again, and it will distort your production process. So for you to enjoy this learning experience curve, your labor turnover should be fairly constant. Okay, so much for talking about labor and learning curve. Let's go into the problem and see how we can solve learning curve problems. All right, just a moment. That's fine. Exercise 4.1. Daily Company Limited has developed a new product. Details are as follows. Now you see the bold type subheadings for each paragraph here. This one says selling price and product life cycle. A product will have a life cycle of 10,000 units. Now, what does this statement mean? It means that throughout the product life, only 10,000 units to be produced. Nothing more, nothing less. It is estimated that the first 9,000 units will be sold for 3,100 naira each. So we have the selling price for the first 9,000 units. And then the product will enter into the decline stage of its life cycle. So you see here, they have talked about selling price for the first 9,000 units. That's why you see the topic, the heading there, selling price for the first 9,000 units. And now there is a product life cycle. There are 4 stages in the product life cycle. We have the introduction stage, we have the growth stage, we have the development stage, and we have or the maturity stage, and we have the decline stage. So the first 9,000 we go through from the introduction down to the maturity stage. Then after the 9,000 is sold, the decline stage will now be staring us in the face. That means the last 1,000 units will be in a decline stage. Let's read on. It is difficult to forecast the selling price for the 1,000 units that will be sold during this decline stage. So what are we saying here? We have selling price for 9,000 units, which is said to be 3,100. We don't know the selling price for 1,000 units. It is my bet that you will be asked to find a way to get a selling price for this 1,000 units. Let's read on. Look at costs. Now, labor will be paid at 300 naira per hour. It means they have given us our labor cost per hour. So the thing you'll be thinking in your mind is, how many hours of labor will be involved? Because if you know the total number of hours, if you multiply that by 300, you will know your labor cost, isn't it? Let's see if it will be given. Other variable costs. Okay, so you see now they are differentiating labor from other variable costs, because normally we know that variable cost includes material, labor, and maybe production overhead or variable overhead. So they separated labor and they are telling you other variable costs. Now it means these other ones like material and production variable costs will be 950 naira per unit. So why are they separating labor cost per unit? Or they didn't even tell us per unit, it's per hour. Why are they telling us labor cost per hour different from other variable costs? And we are told other variable cost is given to us in per unit. The simple answer is this: labor, you get the labor details when we get to learning curve. Now they have given you labor hour, hourly rates. We don't know the labor hours. So it is my bet that your value of measure for A will be hours, because we want to know the labor hours. So I'm expecting that all I will be finding in learning curve will be hours, so that when I get my total labor hours, I will now be multiplying it by 300 naira. I have tried to forecast how the value will be. I don't know what the measure is going to be, whether it's going to be unit or whether it's going to be batch. But look at how we will do that. All right, they said fixed cost over the life cycle of the product will be 2 million naira. That means for the whole 10,000 units, the fixed cost we are going to spend is 2 million naira. We are not told that the labor rate, which is 300 naira, and other costs, meaning the 950 as well as the 2 million, will not change throughout the product life cycle. That's beautiful. Now let's get to learning curve. This is where you want to pay attention. Take notes. The first batch. Hold on a moment. Whenever you hear the word first, look at what comes after first. That tells you the unit of measure. So the first, hold on, first what? First batch, meaning that your unit of measure is batch, not units. So it means that anytime unit is measured or is mentioned, you have to convert those units to what? To batches, because your answers will have to be in batch. Let's read it again. The first batch of 100 units. So when they mention batch, know that they will be you'll be given the batch size. They not told you the first batch of 100 units, meaning 100 units make one batch. Now, it means that if they keep telling you units, just be converting it to batch by dividing those units by 100 to get how many batches. So if they tell you 10,000 units, divide the 10,000 units by 100, you get 100 batches. We'll read it again. The first batch of 100 units will take 1,500 labor hours. Hold on. We are getting the units, or the measure, the value of measure. So we said step 1, look out for units of measure. We've seen that is batch. Step 2, look for the value of measure. It's going to be either hours or naira. And I told you before, they've given you labor price. So I don't think it's going to be naira value. And I've been vindicated. It's stated here 1,500 labor hours. That means your value of measure will be in hours. So two things. A is driving the process, the whole thing. Your answers will be in hours. And that hours is to measure batches. How many hours to do certain number of batches? That is the direction of this question. Let's read on. There will be an 85% learning curve. If I were you, when I hear 85% learning curve, I will just stop immediately and look for my B. So what is your B? Your B is log 0.85 divided by log 2. Whatever answer you got, that is your B. So you write it down somewhere. And you check if your B is given to you. Let's read again. There will be an 85% learning curve that will continue until 6,400 units have been produced. Let's stop so far. So you see, you start learning from the first batch. Now, I said because they told you batch, subsequently they now start saying units. You will need to convert those units to batch. So it means that 6,400 units divided by 100 will give you 64 batch. So it means you have to now rephrase this question and say there will be an 85% learning curve that will continue until 64 batches have been produced. But that's the way to read it. Now, any batch produced after this level. So you see, they want to confuse you. They mention unit, they did not come to batch. So I told you be consistent. So you see, any batch produced after this level, what does that mean? It means that after you've made 64 batches, any batch, that means from batch 65, which is being produced after batch 64, will take the same amount as the what? 64th batch. Now they've mentioned the word 64th batch. It means that you are going to be doing your big T and especially that small t, incremental value. It means that you are going to be looking at how many hours does it take to move from 63 batch, okay, from the 63rd batch to the 64th batch. So you're going to be applying something like small t equals to the total time it takes you to do 64 batches minus the total time it will take you to do 63 batches, all cumulatively. That is the only way to get the amount of the 64th batch. Let's read it again. It says, any batch produced after this level will take the same amount as the 64th batch. Meaning that when you get the 64th batch, that small t, you multiply it by the number of batches from 65 to 100. So batch 65 to batch 100 will give you 36. So it means that whatever that small t is, you're going to multiply it by 36 to give you the total time it takes you to produce those remaining 36 batches after learning has ended. So it means that you are doing two things. One, you are looking for the total time it will take you from batch 1 to batch 64. That is the learning period. Secondly, you are going to be looking for the time it takes you to do just the 64th batch, which means going from batch 63 to batch 64. Then using that figure, you're going to use it to multiply how many units you made from batch 65 to batch 100. Now, watch how we're going to do that in this question. Then I said the batch size is constant at 100 units. They are reiterating that one batch is 100 units. Required. Calculate the cumulative average time per batch for the first 64 batches. Now, you mean that you need to know what this thing is telling you. Which parameter are they asking you to calculate? So remember I said Y is the cumulative average. Y is an average figure. Cumulative average time per batch for the first 64 batches. What does this mean? It means your X is 64 already. You know your A. Your A is 1,500. It doesn't change. Your B is whatever you are given. Okay, they give us the B. The learning index for an 85% learning curve is minus 0.2345. You need to check it. Okay, so if your learning curve is a positive number, it's wrong. It's always going to be a negative number. You know why? Because when you are looking for the logarithm of anything 0 points to give you negative. All right. Now, when you confirm what B is, your A and your B will always be the same. Your X is what they will be giving you as independent. You are not to find Y. So Y is the cumulative average time per batch for the first 64 batches. Now let's solve it. How do we solve this problem? Let's get to page 3. Very good. Now look at the solution here. All this reiterate what I was saying. Note the following. A equals to first batch, 1,500 hours per batch. And we are told that one batch equals to 100. We are saying that since the unit of A is given in terms of batch, the formula we'll be using will be in terms of batch. Also, the value of A is given to us in terms of hours. So we are going to be doing something like maybe 5,000 hours per batch. Things like that. You'll be expressing things in hours per batch. Now we are given X is 64 batches cumulatively. It means we are calculating first batch down to the 64th batch. Or if you want, you can say the first 6,400 units. And we are told that learning stops after the 64th batch. And we are told that anything produced after the 64th batch, that is from batch 65 to batch 100, we use a steady labor hour, which we will get when we calculate the 64th batch. This is just a summary. Let's do the real thing. We are to find the cumulative average time, which is Y, when X is 64. So what do? We write our equation. Your A is 1,500, your X is 64, your B was given raised to power minus 0.2345. Now in your calculator, always do that thing that is having power first. So press 64. If you have your calculator there, let's do it together. You type 64. Then you press that caret sign, that inverted V, or you can say that A that is not complete, or inverted V. In your calculator, if you don't have that sign, you might see something X raised to power Y. Press that calculator press that figure or that symbol after you've pressed 64. You have activated the power sign. Then you type the power figure minus 0.2345. When you do that, if you press equal to, what you have there is you've done 64 raised to power minus 0.2345. Then you now press your multiplication sign, multiply by your 1,500. When you press the equal to, you have a value for Y. And your value for Y from that way of calculation will give you 565 naira points, 565.64 hours. Now, I want you to be giving your answers in decimal form, because the more you approximate to the nearest whole number, the more error prone your answers are. So sometimes I favor answers that has 4 decimal. The higher number of decimal gives you a closer answer that is correct. So between 2 decimal units to 4 decimal units is the standard you should give your value for Y. I have taken 2 decimal, so we've answered the first part of the question. Find the cumulative average time per batch for the first 64 batch. It means that although you started by using 1,500 hours to make one batch, now by the time you've gotten to the 64th batch and they now average everything, it's as though when you were doing everything, you have been using 565.64 hours per averagely for each of the batches till you get to 64 batch. All right, so let's look at the second part of the question, the time taken for the 64th batch. Now, what do we need here? The time taken for the 64th batch. What do we need to do? One, we already know the value of Y when X is 64, which is this value we just found now. That is the value of Y when X is 64. What we are going to do now is we need to now know the total number of hours it takes us to do from batch 1 to batch 64. I told you normally we are supposed to look for total first before average. But now our formula says do average first. So you have to now convert to total. Now, how do you find the total, which is T when X is 64? You use this formula, T equals to X multiplied by Y. Simply say, if you look at it here, you simply say Y, X is 64, Y is 565.64. When you multiply them together, you have 36,200.96 hours. Now you've gotten the total number of hours it takes you from that first time you started with 1,005 down to the 64th batch you are right now. But that's not all. what you've succeeded in doing is the total time taken for 64 batches. We now said you're going to repeat that same process, but this time go one step lower. Find the value of y when x is now 63. In other words, we are having x minus 1, so 64 minus 1 is 63. So look for the value of y when x is 63. Then go back again to look for the value of t when x is 63. When you do that, you now apply this small t formula. Look at the small t formula. Total small t will give you the big T when x is 64 batches minus the big T when x is 63 batches. Now, that is the small t you're looking for. That is the steady state time, and that is the time taken for the 64th batch. Let's do that together. We've done y before. We just calculated t right now together. So let's go to look for y when x is 63. Do the same thing as before, but the only thing that changes here is in the first one, y was 63, now 64, but now y is 63. So go again and in your calculator, press 63. Press that power figure, that caret figure, raised to power, put that same value here. When you raise the value of 63 by this, any answer you got, multiplied by this 1,500 constant here, and now you get 567.735 hours per unit. Now you've gotten something. I want you to notice something here. When we look for y when x was 64, we got 565.64. Now when x was 63, we are getting something higher. Now that's to show that you are correct. Why is it so? Because as you keep producing more, the average hours keep reducing. You know, it started from 1.5. By the time you make the first 2 batches, it would have reduced from 1.5 to maybe to 1.2 per hour, per batch. Maybe by the time you go to 4 batches, it will have reduced from 1.2 to perhaps 1,000. You do that, like that. So you see, when it is at 63, the average will be higher than when you get to 64. So you see, if you get something lower than what you got in 64, that's a sign that you made some mistake. So your average for 63 is expected to be higher than 64, because when you get to 64, your efficiency should be clearly seen. Now that you've gotten that for x, for y when x is 63, let's look for the total for the total value when x is 63. So you do the same thing, multiply 63 by this figure you just got now, and that gives you 35,676.3 hours. Now, simply because I told you when you are checking y, the y for 64 should be smaller than the y for 63, but also for t. The t for 64 should be bigger than the t for 63. Of course, you are using, if you look at it now, you are using this figure to multiply 64 and using this other figure to multiply 63. Look at it also critically. You expect the total time taken from batch 1 to batch 64 to be bigger than the total time taken from batch 1 to batch 63. So you see, note that average of 64 when compared with average for 63, there should be an improvement when you get to 64. So 64 average should be lower than 63. But when you're looking at total, 64's total will be bigger than 63. That's an interesting point I just wanted to know. Okay, so you now look at the T64th batch, means you're looking for the time taken for the 64th batch. Okay, you now say it is the total time taken for 64 batches, which is 36,200.96 minus the total time taken for 63 batches, which is 35,766.31. When you minus it, you have 433.65. Now, this 433.65 is the time you took just after finishing batch 63. That is the actual number of time it took you to do batch 64 alone. It took you 36,200.96 to do from batch 1 to batch 63, to batch 64. It took you 35,767.31 to do from batch 1 to batch 63. But how many minutes or hours did it take you to do just 64th batch alone? 433.65. Now, that figure is your steady state figure. That's the figure you'll be using for planning purposes. Now, let's go to the C part of the question where you'll be applying all of these. C part says the average selling price of the final 1,000 units. Hold on. I told you they gave us the selling price for 9,000 units, and we said it was 3,100. The product entered decline cycle. And we were not told how much is the selling price for the last 1,000 units. And they said it is difficult to forecast. They are now asking you to calculate the average selling price for that 1,000 units. Now, there's a condition that will allow Daily Company Limited to earn a total profit of 2.5 million from the products. So, how do we solve this? Let's see. Look at the process. You know, a profit statement will start from sales revenue, which is this here, sales revenue. You now normally less your variable cost from it, right? Which will give you your contribution. We already know that. If you remove your fixed cost from your contribution, what you'll be left with is your profit, or I would say your targeted profit. Now, let's assume that we want to start from bottom to achieve the top position. So it means that we'll start from the target profit. What do we do? Here, before we less fixed cost from contribution to get target profit, we do the opposite. We add the fixed cost to give you the contribution. Now, after getting fixed cost to get contribution, previously, when we less variable cost from sales revenue, we got contribution. So if we are moving up, we are going to be adding back our variable cost to give you sales revenue. Now, that's not all. We are going to be separating the sales revenue of the 9,000 units from the sales revenue of the 1,000 units. And you can know your sales revenue by saying sales quantity multiplied by the selling price. So it is easy to get that of 9,000 units. So you remove 9,000 units from this sales revenue, because this sales revenue is for the whole 1,000, for the whole 10,000. So when you remove that of 9,000, which is easy to calculate, you now have the sales revenue for 1,000 units. But what are we asked to find? Selling price. We know that sales revenue is sales quantity times selling price. If sales price is the subject of formula, it means your sales price will be your sales revenue divided by sales quantity. That is the way we will go. All right, let's go. The question says that one, we want to make a target profit of 2,500,000. That's our starting point. Target profit 2,500,000. We're now going to add our fixed cost to that. What is our fixed cost? We are told is going to be 2 million naira. So we add the 2 million naira to that, becomes contribution is now 4,500,000. Good. We are now told that we must add our variable costs. For us to add our variable costs, we are given things here. We are given other variable costs, 950. We are given labor cost, 300 naira per hour. Let's apply this. Other variable cost, that's what we want to take first now. We have 950 per unit. And how many units did we do all in the life cycle? 10,000 units. So when you multiply by 950, you are having 9,500,000. Now let's keep it somewhere. Let's go now to deal with labor costs. I told you we are going to be looking at the learning stage and the non-learning stage. All right. During the learning stage, we made 64 batches. How many hours did it take you to do 64 batches? I'll take it up again. It took us 36,200 plus 96 to make 64 batches. That was during the learning stage. If you multiply this figure by 300, which is what we did here, you would have gotten 10,860,288. This is the cost, what it cost us during the learning period. Now, after the learning period, we said any batch produced after the 64th batch will take the cost that was used to making that 64th batch. And in our calculation, we got a figure of 433.65 naira hours per batch. So 433.65 hours per batch. Now, how many batches are there from batch 65 to batch 100? Look at what I usually do. I will say 100 minus the 64 batches. That will give me 36. That means from batch 65 to batch 100, we have 36 batches. So you multiply 433.65 times 36 batches. That will give you the total hours for the remainder. If you now multiply it by 300 naira per hour, it means your cost for the after learning stage is 4,683,420. Now, when you add the learning stage costs with the non-learning stage, after the learning stage cost, you add the two together, you are getting 15,543,708. So that means this 15,543,708 is the total labor cost, which comprise of the cost during the learning stage of 10 million and fraction, and the after learning stage of 4 million and some fraction. Now, we still are under our variable costs. So our other variable cost was 9,500,000. Our labor cost is 15,543,708. You add those two together, your total variable cost will now become 25,043,708. That is your total variable cost. And what do we do with that? We add it to our contribution. So we add that to 4 million, we are getting a total sales revenue of 29,543,708. That is the sales revenue for 10,000 units, which is like saying 100 batch. Now, we are told that 9,000 units, we know their selling price. So it means we can easily calculate the sales revenue for 9,000 units. So let's look for that. 9,000 units multiplied by 3,100. That you can remember, the selling price is 3,100. When you do that, you have 27,900,000. So what do we do? If we remove the sales revenue of 9,000 units from that of the whole 10,000 units, we are having the sales revenue for the remaining 1,000 units, which is 1,643,708. But the question is the selling price we want to get. How do we get the selling price? Selling price or sales revenue is quantity times selling price. Selling price is the subject of formula. Selling price is the subject of formula. Okay, sorry. Selling price is the subject of formula. And how do we do that? The quantity is 1,000. The sales revenue is 1,643,708. So that would be 1,643,708 divided by 1,000 units. It means our final selling price is 1,643.71. You can confidently approximate it to 1,644 naira. So that is the selling price. So you can see all the trouble we went just to get this final selling price for that product in the decline stage, just to meet a particular target. So you see all the troubles we went through. So come to think of it, if your workers are, people who leave their jobs, absent themselves, they are not fairly constant, you will not be having your learning curve smoothly. You will not be getting your labor costs correctly. That will be a challenge for you. So for the past 1 hour, almost 1 hour, 20 minutes, we've been talking about learning curve, and we've taken just one question. Now let's look at a second question, and let's take learning curve to a different level. Akoko PLC has recently developed a new product called Echo, which has been in production for the past year. The plant producing Echo is shut down for routine inspection and maintenance every 3 months. And during the first year's operation, the costs and shutdown have been as follows. Now look at the quarter. We have the first quarter down to the fourth quarter. Look at the cost that is associated to the quarters. If you notice here that quarter 2 cost is lower, slightly lower than quarter 1's cost, it gets gradually reduced up to the fourth quarter. Now, the management accountant attempts to forecast maintenance costs for the coming year. And on examining the above data, it appears that these costs have been steadily decreasing. I mentioned it. The plant engineers have suggested that this is probably due to the fact that the maintenance engineers are becoming more used to the procedures involved. So you see, they are becoming more used to the procedures involved. At first, they may not be more used to it, so they spend a lot of time. Imagine they spend 36,000 hours the first quarter. As they are becoming more used, they are spending less time learning and experience. And then I said, and also the fact that the plant itself is gradually settling down after initial operational problems. If this is the case, an appropriate learning curve could explain the situation which has been observed. Required, explain the concept of learning curve. Okay, let's go down there to see the solution. Now, look at the concept of learning curve. The basic concept of a learning curve is that the more a particular task is performed, the more proficient the individual becomes. And as a consequence, the time taken decreases, as you can see in that case there. In the initial stages, the learning effect is substantial, leading to a marked decrease in time. So you see, the first time the learning effect, when the learning effect is observed, it is so substantial that, wow, when you learning curve for the first time and you are practicing it, you see that the learning rate increases, or it decreases the time it takes to solve the problem the first time. And as you practice, you become more proficient. That is why I tell students, don't start and do fire brigade approach. Some tell me, I have not started reading. You have supposed to start reading from June. This lecture started in July. Why some will be waiting to start reading in August or in September? But you are allowing learning curve to walk through you. You start experiencing learning curve early enough so that when you practice, you get to the steady state which you will now use in the exam. Let's go back to this question. Okay, we now said in the initial stages, the learning effect is substantial, leading to marked decreases in time. In later stages, however, the individual becomes more familiar with the task and the rate of learning slows down. This effect is captured in a relationship between the average time taken per unit and the cumulative number of units produced or task repetitions. Now the relationship is in this form here, y equals to ax raised to power b. And there is another equation here, b equal to log r all over log 2. This is the simple answer for part A. Let's go to part B. Estimate the learning rate, which is inherent in the data. Explain the meaning of the value you've calculated. Now, wait a minute. What are we asked to find here? Estimate the learning rate, which means you were not given R. You are the one to look for R. This is different from, now take note, this is different from you are given R and you are not given B. You now use log R divided by log B to get your, divided by log 2 to get your B. But hold on, you are not given B. You are not given R, and you are asked to look for R. I need to take a sip of water before I continue. What do you need to do? I can factor in 2 ways of doing this. One of them is using the logarithm way. where you need to take the log and you take anti-log, you take log twice, then you take anti-log. But for those of us who are not good with maths, that is going to be a long step and it's going to be difficult for you to understand. So I'm not going to do that. Now, thankfully, I'm going to use a shorter method, which is in sync with what we've learned about learning curve. Now, I want you to observe the way I'm going to use the concept of learning curve, which you've learned, to look for the rate inherent in the data. All right, B. In this question, the value of B and that of arrow were not given. We must now apply the principle of learning curve and the knowledge of logarithm to solve this. Now look at this. Learning curve theory. Look at the theory I'm going to be using. As production doubles cumulatively, the average shutdown costs reduces by a constant percent known as the learning rate. Now in this question, the only way we can solve it is using the tabular form. Now let's analyze what we have been given. The quarters are independent, so I target X. So you now know your X. X is 1, 2, 3, 4. That's fine. Shutdown costs. That is the shutdown costs. It's neither X, it's neither Y. Now, look at what we are going to do now. We are going to be looking for T. So we are doing the normal thing. We're not using the formula. We are doing the normal thing where we'll get your T. I told you to look for the total age of 5 boys and then look for the average. So we're not using the formula where we look for average first, then we'll get T. So let's go. If the shutdown cost for the first quarter is 36, cumulative as at the first quarter is going to be 36. Let's hold it. What is going to be the average for the first quarter so far? It means 36 divided by 1. That will give me 36. So you see here, we've gotten our T, 36, cumulative T then. We've gotten our average, which is Y, which is 36. Now let's go further. Second quarter, we are told the cost is 28,800. So what is going to be the cumulative cost when you add the first and the second quarter to become 64,800? That's the cumulative cost. So what is going to be the average cost per quarter? It's going to be 64,800 divided by 2. That gives me 32,400. We'll go to the third quarter. Okay, we now said it's 27,000. So what is the cumulative? Meaning first quarter, second quarter, third quarter. It gives you 91,800. What is the average? 91,800 divided by 3, 30,600. Then we'll go to the fourth quarter. We are told it's 25,200. What is the cumulative? 117,000. And now what's the average? 117,000 divided by 4 is 29,250. This is the first part of getting the answer. What's the second part? Now, we will now test this data. We now say, as production doubles cumulatively from quarter 1 to quarter 2, what will happen? Look at quarter 1 to quarter 2. If production, now we'll change it from production. If costs goes from quarter 1 to quarter 2, the average cost reduces. Now look at the average. The average cost reduces from 36 to 32,400, meaning that because production has doubled, movement has doubled, the learning rate will now be seen. It's reduced by a constant percentage. Now, this means that the average cost, 36,000, can be reduced to an average cost of 32,400 by applying the learning rate. So you see here, look at the 36,000. You want to reduce it by the learning rate. So you multiply it by the learning rate, it's going to give you the other costs. So what does that mean? You make R the subject of formula. By doing that, it means 32,400 divided by 36,000 gives you 0.9, which means this is 90,000, 90% rather, 90%. Your learning rate here is 90%. But let's not get ahead of ourselves. Only used it in just 2 of the data, quarter 1 to quarter 2. How am I sure it's going to affect everything? So we confirm. As production doubles from quarter 2 to quarter 4. So you see the doubling effect here. The average cost reduces from what to what? From 32,400 to 29,250. So let's apply the same method when it's going to be reducing from 32,400 multiplied by the learning rate, it's going to give you 29,400. So if the learning rate remains the same, that means it's all true. When we do that, we get 90% as our learning rate. So that means the learning rate inherent in the data is 90%. Take note of the simple but logical way we arrived at this 90%. First, we tested it from moving from quarter 1 to quarter 2 cumulatively. Then we test it from moving from quarter 2 that we just found to quarter 4 cumulatively. Let's go to the C part of the question. It says, using the learning rate that you have determined, that is 90%, forecast a total cost of shutdown for routine maintenance during the coming year. What are they telling us? We already know the first year, which is the total cost for first year. We know is 117,000. Now they are telling you to find the shutdown costs for the coming year. So the first year has 4 quarters. The coming year, which is the second year, would also have 4 quarters. So we are going to apply this doubling effect again. So we said before, as production doubles from quarter 1 to quarter 2, remember that the learning rate is easily seen, 90%. As production doubles again from quarter 2 to quarter 4, that same 90% was inherent. So we're going to say now, as production doubles from quarter 4 to quarter 8. So you see, if you add year 1 that has 4 quarters with year 2 that has 4 quarters, it's going to give you 8 quarters. So as production doubles from quarter 4 down to quarter 8, the same 90%, which is inherent in the data, should be seen. So let's see how we're going to apply it. So that's what we said here. As production doubles from quarter 4 to quarter 8, the shutdown costs will reduce by 90%. So this is what we did here. Look at the quarter 4 costs. When you multiply it by 90%, this will give you your quarter 8 costs. This is the quarter 8 cost alone. That is the quarter 8 cost alone. Now let's look at it now. Okay, so this is the total, this is the value of x, value of y when x is 8. This is not the quarter 8 cost alone, sorry. This is the average cost per quarter from quarter 1 down to quarter 8. Now, let's look at the total cost itself. It means that you are looking for the value of t when x is 8. It means you've gotten the average, which you have here, 26,225 multiplied by 8. It gives you the total cost for 8 quarters, which means that for year 1 and year 2, which is 8 quarters, the 2 years figure gives you 210,600. But hold on, we only are asked to look for quarter 2 costs, for year 2 costs, not year 1 and year 2. So we already know year 1 cost is 117,000. So when we remove year 1 cost from year 1 and year 2 costs, we have 93,600 alone for quarter 2 costs. So notice the technique we used. We used the doubling effect. We used as production increased from quarter 1 to quarter 2. We saw a 90% effect. From cumulatively from quarter 2 to quarter 4, we saw the same 90% effect. And we are now saying that each year has 4 quarters. So quarter 1 is year 1 is 4 quarters, year 2 is 4 quarters. So you merge them together, you have 8 quarters. So we now say as production doubles from quarter 1, which is the end of year 1, to quarter 8, which is the end of year 2, we will also observe the 90% inherent in the data. And when we did that, we have the average per quarter from quarter 1 down to quarter 8. What did we do? We look for total for 8 quarters. Since we have the average for 8 quarters, we multiply the average for 8 quarters times 8. We get the total for 8 quarters. But we don't want to get 8 quarters figure. We only want to get 4 quarters belonging to year 2. All we need to do is remove the first 4 quarters we found out to be 117. And that means the remaining 4 quarters that makes up year 2 figure is 93,600. It is so interesting. Let's get to the fourth question. The fourth part, it says, assume that learning ceases at the end of second year. Hold on a moment. It means that learning ends at the 8th quarter. Now, what does that tell you? It means that moving from quarter 7 to quarter 8, you will get the 8th quarter costs. You will get the 8th quarter cost alone, which we will call the steady costs. You can now use it to plan for the next quarter or for the next year. So let's read it again. Assume that learning ceases at the end of the second year. Forecast the total cost of shut down routine maintenance for the third year. All we simply need to do is look for the total cost for 8 quarters, which we already have. Look for the total cost of 7 quarters, which we'll do. Minus that from 8 quarter, you will get the 8th quarter cost. Use that cost you've gotten for the 8th quarter to multiply by 4 quarters for the third year. Let's apply that situation. Here, learning stops at 8th quarter, so we need to find both y and t when x is 7. Of course, we already know that for 8. Then we shall find the steady cost t at the 8th quarter, which we shall use to multiply the 4 quarters in the third year. That is what I said. Now let's look for the value for of y when x is 7. Use our formula now. Now we are now using the formula. The first 3 questions here, this same question, the first 3 parts, We never touched the formula. We went round using the tabular method. Now we are using the formula. So what is the value of y when x is 7? So you do that. You have to look for your b because we are not giving b. We only looked for y. So let's look for the b now. B is going to be log arrow. Your arrow is 90%, express it as a fraction, as a decimal, which is 0.9. I told you when you are looking for log of anything with 0 points, it gives you a negative figure. Log 2 is 0.3010. When you divide, this is your B. That's a great feat we just got here. Then what is our A? Our A is 36,000, which is this. Your X is 7. Your X is 7. While your B is this power, this thing in power. And I how to go about punching it in your calculator. You press 7 raised to power, you know the symbol for that. Then you get this 0.5120. When you get that out of the calculator, anything you have, you multiply by 36,000, you are going to get your y to be 26,782 points. Can you see 4 decimal places here? This is to ensure I want to get accurate answers. Now you get your y as this figure. Go now to get your t. Your t is simply your x multiplied by y. So your x is 7 here. Your y is what we just calculated. When you multiply, you are getting this answer. Now you can make them a whole number. If you want to, you can make them a whole number. So your t is now 187,476. That's fine. Now this t is for when x is 7. We already have t when x is 8. And we did that in the previous question. And that was this t when x is 8 as 210,600. Now we are going to use it now. We are going to be looking for the total cost of 8 quarters, 210,600, minus the total cost for 7 quarters, which we just calculated now, gives us 187,476. It means that the 8th quarter alone is going to cost us 23,124. Just 1 quarter. So how does that translate to the 3rd year cost? What we'll simply do is multiply this quarter cost we just calculated, the steady cost, by just 4 quarters. That means for the 3rd year, we are going to be spending 92,496. So it means for the 3rd year, this is the cost we're going to spend. For the 4th year, this is the cost we're going to spend. For the 5th year, this is the cost because we are using a steady cost now. Learning curve has been an interesting topic for us to discuss this evening. And you can see that I'm excited explaining this topic to you. So as a way of recap, I want you to look at those 9-10 steps I gave you for solving learning curve. You will never go wrong if you follow those steps. Also, note that learning curve is a doubling effect cumulatively. So it's a cumulative thing, it's a doubling effect. Take your time to look at these questions. Now, these 2 questions I solved here is credited to ICAN past question paper. These are two past question papers from ICANN, crediting them. ICANN within the past from 2014 down to 2020, they have set about 3 or 4 learning curve questions, and we've done 2. I want you to identify the other one or the other ones and solve them and practice, 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 so that when this comes to the exam, you will say, yes, I passed through learning curve. Learning curve is passing through me. And you're going to solve these questions and be satisfied with yourself. Thank you so much for coming to class, and thank you for your patience in listening to me. In the next class, we are going to also take an exciting topic, and we will finish that topic in the class within the 2 hours allocated for the class. Thank you once again, and from me to you, it's good night and have a nice rest.